All right, question 7. Solve the following equation algebraically where 180 degrees is less than theta, which is less than 360 degrees. Our equation is 2 sine squared theta plus 5 cos theta plus 1 equal to 0. So there's a few positives with this question. It's in degrees, so if you remember grade 11, you might be able to do this. The other positive is it's quadratic, so we know that quadratics must equal 0. It already equals 0. What makes this question worth an incredible 4 marks is the fact that it's not that easy. There's no way of factoring this equation if we have a sine squared as our quadratic term and a cos in the middle. So we don't have an identity for cos theta. Cos theta is a primary function. But we do have an identity for sine squared, right? Sine squared plus cos squared equals 1. So where I see sine squared, I could actually put in 1 minus cos squared theta. And this is a very common exam question. When I substitute in, I want to make sure I have brackets because I'm replacing a single term with a binomial. So this is 1 minus cos squared theta. And then everything else is straightforward. And it's not changing, I should say. So let's see. We got 2, distribute the 2. Minus 2 cos squared theta plus 5 cos theta plus 1 equals 0. So I'll just group my like terms here, put my quadratic in front. Minus 2 cos squared theta, first of all. Now I'll group, the 2 and the plus 1. That's going to add up to give me a 3 in the end. But I'll put my cos in the middle. And we don't have good strategies to factor with a negative coefficient. So we could just distribute a negative through, multiply both sides by -1. And we get 2 cos squared theta minus 5 cos theta minus 3. And that equals 0 times -1 is still 0. So we got a little bit of decomposition happening here. So in order to do this question with our decomposition, we want to multiply to get -6, right, because of these two guys right here. And we want to add to get -5. That's not so bad, I don't think. 6 and 1, I think. 6 and 1. And if I'm adding to get -5, I need the 6 to be the -1. I initially thought 3 and 2, but -3 and -2 will give me the -5, but -3 and -2 would give me back a +6. So a little bit tricky, but not too bad. Nothing you didn't see in grade 10 and 11. So 2 cos squared theta minus 6 cos theta plus 1 cos theta minus 3 equals 0. So now we're going to break this up into 2 parts and see what's common. Right? That's how we handle our decomposition problems. So we definitely have a 2 common. We have a cos common. And what's left is cos. And 2 times 3 is 6, so minus 3. Let's just make sure. 2 cos times cos is 2 cos squared. 2 cos times -3 is -6 cos. Yep. This, there's actually nothing we can remove, but just for easiness, or for ease, take out a +1. +1's not going to change anything, but when we factor it, it'll look nicer. So what do we have so far? What we have so far is the common factor of cos theta minus 3. So I got cos theta minus 3. And what's left once I factor that out? Well, 2 cos theta is left. And just the +1. Okay, I can't remember if this is a non-calculator part or calculator part, but definitely can do this with no calculator. We'll solve each factor independently. So cos theta minus 3 equals 0. Cos theta equals 3. Well, cos only ever goes up to, to a height of 1 when you think of the curve. So there is no solution to this. And write no solution. Don't leave it blank. This one, I think there will be a solution. 2 cos theta plus 1 equals 0. 2 cos theta is going to equal your minus 1. And cos theta equals minus 1/2. And if you know your special triangles, you know this is in there. So let me just see if I could draw my special triangle in degree mode. So up here is 30 degrees. Right here is 60 degrees. Opposite 60 is root 3, 2, 1. How do I know that? I memorized it. That's how I know it. So sure to memorize this triangle. So I always prefer, to write what the reference angle is. I use alpha for first. You got to find the reference angle first. So I say my reference angle is, so cos is adjacent. So 1/2. So it's 60 degrees. Now, usually we would say, where's cos negative? And we could do it that way. So where's cos negative? Cos is negative. Well, what's this? All students take calculus. So cos is negative in quadrant 2 and quadrant 3. Because, sine's positive, which means cos is negative in 2. So this is a nice question. My one possible solution is, so if we're in quadrant 2, the end of quadrant 2 is 180. So we got to go back. So 180 minus 60, which is 120. And another possibility is quadrant 3. The start of quadrant 3 is 180. So 180 plus 60, which is 240. Now I just want to make sure both solutions are in the given interval. So I look up here at the question, way up at the top. So they want it between 180 and 360. So there's nothing that we have to throw out because both solutions are between 180 and 360. No, they're not. Sorry. So we do have to throw away one solution here. Okay? So obviously the solution we throw away, and you could lightly cross it out, and you could say not in interval. Not in interval. Okay, so what's the only solution? Theta equals 240 degrees. Okay? And, where this is an interval solution question, we don't have to worry about, general solution. So that's it. 240 degrees is the answer.